Okay, so now this is going to be, this is the equivalent of a linear array of for forces. This is for an electric field, right? So here's this charge A as a positive charge. Here's charge C, which is a negative charge. And we've got the distances, right? And we want to find the electric field. What we're going to do is, since these are in a straight line here, they're going to either add up or subtract, right? And the magnitude is going to be, we're going to get using this thing, K Q over R squared, right? Now, let's just look at this. Because of A, the electric field from A is actually going to be away from A, because a positive charge would be repelled by this positive charge, right? So E of A is going to actually be that way. And C is a negative charge, so it's actually going to be an electric field this way, right? So the electric field due to C, right? The electric field due to C will be toward C, okay? So let's figure this out here. Let's draw some lines here. There's a line, and there's a line, and let's just keep drawing lines there. That'll help us out here, right? Okay, so let's do the E of A is equal to K Q over R squared, right? So it's 8.99 E9, right? I'm not putting the units in just for fun. Okay, so then it's 12.5 E minus 6, and then it's divided by 0.112 squared. Don't forget to square, okay? So KQ over R squared, and then this is times 12.5 E minus 6 divided by 0.112 squared. Wow, that's quite a large number. Okay, so I need to go, my calculator very unhelpfully will not go automatically into scientific notation, so I must do it myself. All right, there it is, 8. It is 8.9585 times 10 to the 6th newtons per coulomb. And this guy is, because it's due to A, we're using A as charge, right? Because it's due to A, it's to the left. Okay? And now let's figure out the electric field due to C. And that's going to be KQ over R squared, right? So it's 8.99 E9 over, and then 187 E minus 6. I tend not to put the minus sign in there, so I'm just going to kind of smudge that out. We'll figure out the direction. Then this direction here is 11.2, so let's see, let's add that up. 3 and 3 and 8.833. Make sure I did that right. That'd be sad to get it wrong. Okay, we're on YouTube. Okay, there we go. Okay, so let's just go. I'm so lazy. I'm going to go second entry, second entry. Let's make this 187. And that's 0.833 squared. I think I got it right. Okay, and then we've got 2.4228 times 10 to the 6 newtons per coulomb. And then this guy, due to C, is going to be towards C, so it's going to be actually to the right. Okay. So what I do in this case, I make things that are to the left negative, things that are to the right positive, and then I just add them up. Okay. So I'm going to go 8.9585 E6 minus, whoops, okay, I need to make that guy minus, and then plus the 2.4228 E6, and I get negative 6.54 times 10 to the 6th newtons per coulomb, right, which negative here means left. Okay, that's how I do it, is ultimately I just figure these out. I look at which way the electric fields would be. It's away from positive toward negative, right? Decide which ones are positive, which ones are negative. I make things to the left negative and things to the right positive in my drawing, and then the answer is tells me. Okay.